Hey, this is the video for HOMEOSTASIS.1. So go ahead and set up a new entry in your Cornell notes. Remember to start a new page for this video. Also check out the essential vocabulary. Today we'll be discussing stimulus, response, feedback, dynamic equilibrium, and homeostasis. So I will give an example using temperature. And this low temperature, when it's really cold outside, this serves as a stimulus. And a stimulus is simply a change in environmental conditions, like temperature in this case, could be also oxygen levels, pH, sunlight. Any environmental conditions that changes is a stimulus. And then our body's going to react in a particular way, and that is known as the response. So how an organism reacts to a change in the environment is the response. So in this case, the stimulus is the cold temperature, and then our body is going to shiver, which moves our muscles really fast, and this movement of the muscles causes a temperature increase because of the friction in the muscles, and that allows our body to warm. Now this can also happen when it gets too hot. The stimulus would be the increased temperature, and our body's response is to sweat. So this perspiration that is released on our skin will eventually evaporate, and this evaporation of the perspiration or the sweat will cause our skin to become cooler, and that will lower our body temperature. So this entire process is known as a feedback loop. Our body's, the stimulus of the hot and cold temperatures, and our body's response between shivering and sweating. A feedback loop is a process in which an organism responds to a stimulus in the environment. Now, one common example is the release of insulin, and insulin is a hormone that can help control our blood glucose levels. Don't worry if you don't really understand it. I would sketch this diagram, but one thing, we'll be discussing this in the future. When blood glucose levels are very high, it causes insulin to be released, and the insulin allows our cells to take in glucose. Now, when insulin is very low, our body releases glucagon, and glucagon is another hormone that causes glycogen to be converted into glucose. In other words, it digests a carbohydrate and it converts it to glucose, which then increases our blood glucose levels. You don't have to know the details. We will be discussing this more in the future. But right now, this process is a common example of feedback. So this is what it looks like if we were to graph it. And this entire process, we get hot, we sweat, we cool down, then we shiver, then we warm up, and this process just keeps happening. Sometimes we get a little bit too hot, and we have to make sure that we cool down, or something could happen. We could have severe illness or injury. So this process back and forth is known as dynamic equilibrium. And dynamic equilibrium, this word dynam, this prefix, it means to change. So this is the constant changing in the environment and our body's constant response to changes in the environment. And the term homeostasis simply means a state of balance within an organism. And another word for homeostasis is dynamic equilibrium. Now, we always use the term maintain homeostasis. We want to keep, maintain means to keep, we want to keep this balance in our body. And it looks, according to this example, whatever the environmental condition, we were keeping or maintaining this homeostasis, except for this little area right here. And this little area could have been a problem. This is when our body did not maintain homeostasis. So what needs to happen is we need to bring it back within the conditions, or we risk injury or death. So it is very important to cool our body in this example, or we could damage some of our body systems. And that is a problem. What I would like you to do is respond to this check for understanding. I hope that this video was informative. I thank you for your attention, and I will see you soon.